Hello everyone, Asaf here for aetutsplus.com, and today we're going to talk about 3D Serpentine. 3D Serpentine is a very cool plugin that basically generates 3D path extrusions inside of After Effects, which basically means these guys. Here, there we go. And here's another one. This one is like a tunnel in this case. And here is another one that comes in and out of the text, and basically these are 3D path extrusions. This is what 3D Serpentine is doing, and it's really useful. It's cool. It does save you the time and trouble of going out to a 3D software. However, you do need to know some very important tips and hints about how to operate it correctly, how it really works, in order to really get it to do what you want and to really get control over everything that happens with the serpents that it generates. So there are a few tutorials out there that I checked out when I was before I created this. There's one on sterneffects.com. There's one that's very basic on digitaljuice.com, and there's also another one on zaxworks.com, which are the makers of Serpentine. But they're all kind of general basic tutorials, and for some reason none of them, and I didn't find any tutorial that addresses an issue with Serpentine that if you already work with it, you definitely know this issue, where it's where if you design somewhat complex paths, these unexpected kinks or twists begin to appear in the serpents. Now, if you tried it, you know. If not, I'm going to save you the trouble in the first place. So this is a two-part tutorial. In this part, I'll show you how to get full control over Serpentine, and in the next part, we'll talk about some creative uses of Serpentine. But let's begin with the basics, how to operate this thing. So let's open let's open a new comp here. I'm going to use a 720p comp at 24 frames per second, and let's start with bringing in Serpentine. It's applied to a solid, which is, you know, like most effects, and let's apply it. When we first apply it, nothing basically happens here, because the way Serpentine works is it needs some motion path, and then it extrudes the motion path into this 3D noodle. So let's create the motion path. To do that, we'll create another solid. Let's call this one path, and from my experience, the best way to do this is 100 by 100. The scale of the path of the solid that you use for the motion path will affect the size of the serpent, or the path extrusion. And from my experience, starting with 100 by 100 is very good, and later on you can change it here in the scaling, which is much better actually. And let's just draw a simple path. Let's bring up the position parameter. Let's make a keyframe, and let's move in time, say 2 seconds. It doesn't really matter at this point. And let's add another keyframe. Okay, so now we have this path. Let's even add some Bezier curves to make it a bit more interesting, and this is basically our path. Now it has to be 3D, it has to be a 3D path. And now after we have that, let's tell Serpentine to extrude this path. There we go. We choose Serpent 1, and then the first option, extrude path, choose this path that we've created, and immediately it's done. We already have a 3D serpent. Let's add a new camera. I'm going to use the 35mm, and as you can see, we already have this full-blown, pretty nice 3D element that is like a noodle, a 3D noodle. So let's just turn off this path here. We don't need to see it at this point. So let's cover some of the basic controls. So the extrusion offset is the one you'll use the most. This is basically what determines how the how you want the serpent to travel along the path. Now I'm gonna skip a few operators, don't worry about it, we'll cover all of them later. And I'm gonna go to here, show past start and show past end. What these allow you to do is they allow the serpent to travel before and after the area that is defined by the motion path. So basically it exists before it starts its motion path that we drew, and then it continues after as well. And this is, again, you can move the camera and you can basically see that it's all working in 3D space very nicely. And this is extrusion offset. Length basically is the length of the serpent. The cross-section shape is basically where we determine the shape of the serpent. So there are a couple of shapes that come with Serpentine. This one is a line, so it's actually a 2D. It gives us this 2D kind of serpent. The rectangles is what we were just on. There's this nice circle that gives me this kind of serpent. Triangle, hexagon, which is kind of cool, a star, and plus, which was very effective when I did that preview that I showed you before. So these are the basic shapes that come with Serpentine, and what's really cool is that you can be really flexible and use your own cross-section layer, and you can even use a text, or you can draw a mask. Let's, for instance, add a text layer. Let's say AE, and we'll have to, it's too small at this point, let's scale it up a little bit, say something like this, and we don't really need to see it. Let's tell Serpentine that this is the cross-section layer that we want to use, AE, and there we go. And immediately you have this 3D text extruded, and also you can play around with it and have it travel along its path and do a whole bunch of things with it, which we'll cover later. So let's do the same thing with a mask. Let's add another solid. Let's call this one mask shape, perhaps. And this one can be comp size because we're gonna cut a mask out of it. I'm gonna hit G to have this pen tool, and you know, just whatever, just to show you the idea. That looks like a really cool shape, right? That's a nice shape right there. Okay, so let's tell Serpentine to use the mask shape, and immediately, as you can see, now we have this this shape. Let's continue with the draft switch here, right here in Serpentine is actually very important. At this point, where there's still not a lot of design added and keyframes and so on, things are still kind of responsive and fluid, even when I don't turn on the draft switch. But as you'll see when you'll start working with it, the draft switch is actually very important, and it allows you to really work smoothly while you're designing, you know, the structure of your animation. And when you deal with design and look and tweaking the actual look and feel and so on, then you should, I would recommend only then to turn on the full quality switch. And you have these numbers here that basically determine, you know, how good is how smooth is the draft level of in the viewer, and how smooth is the best quality. And from my experience, I wouldn't touch the draft. I would keep it at 20. I would turn the best path smoothness, there we go, to 100. And anything above 100 doesn't really make a lot of change, although you can crank it up more and more, but it just slows things down, and 100 seems like a really good number to work with. So we spoke about all of these. We left out path offsets. We'll talk about this later. And here's another thing you can do, a really cool thing. Let's just go back to this, to just a simple rectangle for this. I'm going to show you what scaling and let's delete these two layers. Scaling and Z rotation can do to your serpent, which is really cool. Let's start with scaling. So let's change the camera angle a bit, and let's say that from the beginning of the path, the scale of the solid will be really small. Let's just look at the solid for a moment. So as we can see, it's really small at this point, and when it goes to the end of when it reaches the end, it goes to something like well, let's say 100%. So basically we've animated the scale of the path, and let's also animate the Z rotation. So let's say that from the beginning of the motion path to the end of the path, it goes through 1 revolution. So now we have this spinning and scaling solid on the path, and this directly affects the serpent. So let's update it, and again, as I mentioned, you can update it by going to the draft mode and then back to the quality, full quality mode, or just staying in the draft mode. And what this did is basically what you're seeing. Now the serpent is kind of revolving or rotating, which is pretty cool. And it's also scaling. As you can see here, it's going from that small size to a larger size. And this is where lock scaling to path is something you may want to use. When you lock the scale to the path, what happens is that these scale keyframes affect the serpent even when it's outside the area of the motion path, which may look more natural depending what you want to create. So this is scaling and rotating, the Z rotation on the path, which help you spice up your serpent. Basically these are the basic controls, I would say. This is just to get you started, to give you an idea on you know, how to basically operate the plugin. Now there is a lot more, obviously. As you can see, there's a whole host of features here. You can control the color and the type of tail and head, and you can add maps, reflection maps, and bump maps and color maps, and there's different rendering modes. There's a lot of things. We'll cover them later, but now I want to address this issue that I mentioned in the beginning. So let's see what happens when I take this path that I've created. Let's just solo it. Actually, let's for now just cancel the scale keyframes and reset them, and also the Z rotation. So now we're back to this path that has just 2 keyframes, and let's add another keyframe and let's see what happens. So let's say we want to have it going something like this, where the serpent is basically doing this this spin here, and let's add this curve here as well. Okay, so right now I just added one keyframe and I kind of adjusted the motion path to sort of look like a rotated U. And let's see what happens to the serpent. So let's refresh, and for some reason now, as you can see, there's this kink or this twist that happens to the serpent, and I'm reminding you that we deleted the Z rotation keyframes, so we're not supposed to have any kind of twists. We're supposed to have just a clean, smooth, straight curve that is happening here. So why is this happening? And we can see that if we animate the extrusion offset, we can see that it is actually twisting for some reason. So what is really happening here? Basically, it seems that when there is more than 2 keyframes on the motion path for the serpent, Serpentine is now extruding the path based on the orientation of the solid, or in other words, where the solid is looking. So for instance, here is one of the ready-made paths that that come with Serpentine. There's a bunch of project files with ready-made paths, and here's one of them. So as you can see, it's some sort of a spiral, and as you can see, there are orientation keyframes in addition to the position keyframes. And these orientation keyframes here are basically what makes sure that the path will be extruded in the right direction, that it will look in the right way, so that it will be extruded in the right way. And this is basically what should prevent unexpected kinks or twists in the serpent. Now, Serpentine offers you to use these auto orientation options. The first one, which is now the default, is segment by segment. And as we can see, it's not really working that well, because this twist here, this one, is not supposed to be here, and also there's another one right here that that shouldn't be there actually. And if we change it to based on curvature, then we see that we get a much smoother and a correct extrusion of the path. If you want, we can just solo the path for a second and look at it, and you can understand how it goes. We'll just look at it like this. So it's a basic kind of a spiral or a coil, and based on curvature works nicely here. And because we have these orientation keyframes, as I said, even if we choose none, the spiral is still extruded correctly. Perhaps it looks even better this way. Now, just to make the point, if this is set to none and we delete the orientation keyframes, what will happen? Let's refresh. What will happen is that now the serpent is really not extruded correctly, and well, I don't want to say what it looks like. It just doesn't look like anything correct. Let's undo that. Okay, so that's the idea. So basically, we understand what we need to do. We need to create these orientation keyframes to be there along with the position keyframes. so that we can have a smooth serpent. Let's try to do that just to understand what it involves. So basically I need to look at my solid and add these orientation keyframes. Let's add the first one. I'm gonna hit U. Let's make sure that it's here. The rotation tool is set to affect the orientation and not the rotation, because I'll remind you that orientation is the thing that determines the correct extrusion of the path. Rotation, the Z rotation, is what we use to control the spinning of the rotating of the serpent itself. So let's just adjust this orientation, so something like this. And as you can see, it's not that instinctive. You have to kind of look at it from the various angles using the camera, and then that's it. I think that'll be the first keyframe. And then as the serpent advances towards here, towards this area of the path, we need to tweak that again. So let's say that by the time that it reaches this keyframe, this position keyframe here, it already needs to be halfway flipped on the x-axis, something like this. And at this point, probably already something like this, and now like this. And let's see, we also have to shift the Y a little bit. And as you can see, this is quite a tedious process to get this thing to look correctly, and because this will affect how the serpent will look like. Let's say that this is what we want, although here I see this should be fixed as well. It shouldn't start spinning on the X that much. At this point it should only be something like this. So let's say that we're happy with this, and you can already see that this method, this manual method of keyframing the orientation, takes time and it's tedious. Now, as we can see, this is still twisted. Let's go to the Serpentine controls, and we should cancel the auto orientation and set it to none. And now it's using only our orientation keyframes that we created. So basically, right now we have this smooth serpent, but this is basically the way, or a manual way to create the serpent we want without that twist that we had before. However, as you can see, depending on your on the complexity of your path, this could be really a lot of work. Now, not only it could be a lot of work, the worst thing that can happen is if you want to modify your path for some reason. Let's say you created some sort of a spirally path, and now you want it to be straight at some point. So now you have to modify the path, which means you have to recreate all those orientation keyframes. In short, that's not fun. And this is why I made this tutorial, to come up with something that is easier and faster and will save you some time. So you guys perhaps are already thinking in this direction, and this is, what about the auto orient, After Effects auto orientation for the solid, which is to orient it along the path. And that's exactly what I was thinking. So let's try to do that and see what happens. Let's solo the path and let's get rid of those orientation keyframes. Let's reset this orientation parameter. And now by Control plus Alt plus O on the PC, I will choose, I get this auto orientation dialog, and I will choose orient along path. And what this does is in a moment I already have this solid that is orienting, seems to be orienting correctly along the path. And let's look at the serpent, and for some reason we're still getting that twist that we got before we manually keyframed the orientation. It's still the same thing. So what is happening here? Okay, so this requires your eagle eyes. Look here. What seems to be like a correct orientation is actually not that correct. For some reason, After Effects has a problem when we want to when it orients a solid along a path, and the path has it is forcing the solid to flip vertically. After Effects is having a hard time doing that. Let me explain exactly what is happening here. Just for the demonstration, let's just add a ramp here to the solid. Let's just make it with whatever color, just something that will stand out so we can understand what we're looking at. In a moment you'll see what I mean. And I'm just creating a differentiation between the upper part and the lower part of this solid. Let's also use the text effect, the basic text, to add text here. Let's call it path. Again, this is just for demonstration. And let's turn on composite and original so we can see what's happening here. Okay, so the solid is starting its race. What should happen is that because there is a flip here, there is this curve, it should be flipping upside down, which means that the yellow part, which was up here, should now be down on the bottom. And what we see is that actually this is not spinning correctly, because the yellow part is still on top. So what's really happening here, and if you really want to understand what is happening here, this is why I added the text. Again, the text should be now written upside down, but it's not. It's actually reflected. And this basically means that what's happening here is that the rotation or the orientation is, there's a flip that is happening on the z-axis, and it shouldn't happen. Basically, it should happen on the x-axis. It should happen correctly, and it doesn't. And there's a lot of actually information about it. You can go to creativecow.net or just Google something like 3D orientation in After Effects, twists and flips or something like that, and you'll see that apparently this is something inherent within After Effects. But I've done that research for you, so you don't need to. While I was researching this issue, trying to understand why is this happening, I found Dan Abbott's expression, which is going to be the tool or the cure for this situation. Dan Abbott's expression, Dan Abbott's, in case you don't know, which I doubt, is a genius in After Effects expressions. Go to motionscript.com and see some of the things that he created. Very useful expressions for anyone. So This expression, which was posted on creativecow.net, is basically an expression that allows you to extract the coordinates of 3D orientation. Basically, it takes the 3D orientation data of a layer and it gives you the actual coordinates. So let's copy this expression to the clipboard for now. Let's delete this path and actually start off with a new path. Let's make it this time even a bit more complex. So let's bring up the position keyframe, add a keyframe, and jump in time, add another one, and another one. Let's make a bigger curve here, something like this perhaps, and let's make it 3D. And now actually let's add another keyframe. Let's push it in Z space a bit. Then let's add another one. And okay, I think that pretty much will help us show the point. So here is our another path, and it's even more complex than the previous one. And let's start by again turning on the orient along path. So again, we now have this path and we have this solid, and if you can see it, again we have this twist problem, this flip. If you look at the green arrow, it's supposed to be here below, and it's up. It keeps being up, and we have another curve here that is happening, this kind of turn, and we have Dan Abert's expression copied to the clipboard. Now let's alt-click the orientation and paste it. So now here's Dan Abert's expression, and it's now set to a layer named layer 1. Let's change it to path because that's the layer that we're working on. And look at here. What I got now is basically the numbers, the coordinates of the 3D orientation. So my thought was that if I grab hold of these numbers and then I can change only the problematic areas, instead of creating all those orientation keyframes for the entire motion path, I can just go to the point where there is a problem and solve it locally, and that's it. So here's what you want to do. You go to the orientation, select it, choose animation menu, keyframe assistant, and convert the expression to keyframes. After we've done that, we no longer need the orient along path turned on, so let's turn it off. And right now what we have is just like we had the orient along path before. Same thing, only now these are keyframes rather than the automatic orientation along the path. So now I can come only to the problematic area and fix it. But just let's see what would happen if we wouldn't fix it, just to make the problem clear again. So let's extrude the path and look at this. This may seem not that bad. We do see that there is some sort of a kink here, but even this may look smooth enough. The thing is that we're not seeing that there is a twist, and if we animate the serpent, look what happens here. Oh, this is not supposed to happen. And again, this is now auto orientation set to none. If we change it to segment by segment, that's even worse. If we change it to based on curvature, that's even worse. So in essence, there's a problem here. And if we wouldn't use the expression and convert it to keyframes, we would have to set the auto orientation to none and keyframe all the motion path orientation. And instead of this, let's bring this back to 100, and let's fix just the problematic area. So let's solo the path and come up to the point here. There we go. This is exactly where the flip happens. And from this frame exactly, from this frame exactly, I want to select all the previous keyframes and I want to delete them so that I can replace them and fix them. So at this point, the solid should be rotated something like this, and move forward in time, and again fix the orientation, forward in time a little bit, fix the orientation, and almost done here I think. And again hit W and fix it. Let's see how it works now, and it looks like it should be working nicely. And let's check out the serpent and how it looks. Okay, serpent looks much better already. Even the curve here looks better. And of course, if I animate it, now I'm getting a smooth and correct result. So that's basically the idea. And again, think if we would have to keyframe the entire motion path, and again think of an even more complex motion path depending on your project, depending on what you want to create. So this method basically allows you to automate the entire motion path and only deal with manually with the problematic areas. So again, to recap, you have to set the auto orientation in Serpentine to none, and then you turn on the auto orient along path for the solid. Then you add the expression, convert it to keyframes, turn off the orient along path, and only fix the problems manually. That's it. Basically, this technique allows you to really get the best out of Serpentine and to be able to really focus on what you like doing, which is designing and tweaking your serpents to make them look awesome. And that's what we're going to do next in part 2 of this tutorial. Until then, all the best.